Hey, everybody. Last time we were together, we did not talk about the word regular. We talked about polygons and we talked about the interior angles and what they add up to be. We talked about the exterior angles and what they add up to be. But we never discussed the word regular, which is really odd. Now, regular has a bunch of different meanings depending on which context you're talking about. A lot of people hear the word regular and they think ordinary. But in geometry, the word regular means something specific. Okay, the image I've drawn right here, this octagon that kind of looks like a stop sign, that I've tried to illustrate what regular is. And regular means that a regular polygon means that all of the sides are the same, or not the same. They all are congruent. All the sides are congruent. Getting ready to write they're the same length, which is what congruent means, but why write all that when I can just write the word congruent? A regular polygon, all the sides are congruent, and not just that, but all of the angles are congruent. And it is possible to have one without the other. Okay, and so, except for a triangle. For a triangle, if all the sides are the same length, all the angles got to be, and if all the angles got to be, then all the sides are. It just works out that way. But there's other shapes that you can deviate, and you can just do one of them. But so a regular polygon means that all the sides are congruent and all the angles are congruent. Both of those things. Okay, for instance, if I had a four-sided figure, I could have something like this that's called a rhombus. And I could say, hey, in this figure, all the sides are the same length, but clearly not all the angles are the same length. Here's one that's obtuse, and this one right here is this little acute angle. So that's not the case. But you should all know a four-sided figure that is regular and what it's called, and that would be a square. A square is a four-sided figure. It's a four-sided polygon where all the angles are the same size and all the sides are the same length or congruent. And so it would be a square. And that's the one that has a pretty nice, simple name. Beyond that, we start just using the word regular, and we say regular pentagon or regular hexagon, regular septagon, or whatever. And we just kind of work our way up right there. But for the four-sided one, we can call it a square. Now, if it's three-sided, as I said, if it's three-sided and the sides are the same length, then the angles kind of automatically are also the same length. And so we could say this right here, and you could give this a few different names. You know, you could call this a regular three-sided polygon. You could do that. That's an accurate name. That's a regular three-sided polygon. You could also just call it an equilateral triangle. Okay? And we said if it's equilateral, if its sides are the same length, then it is also the angles are. And so it could also be called equiangular, an equiangular triangle. Okay? And both of those would be the same. Okay? Equilateral triangle, equiangular triangle, those are potato. Okay? But either way, so those are three different names that we could give this shape right here. All right? And they all fall into this category of regular. Regular means same length sides, or the sides are congruent, and all the angles are congruent. So what I want to do is I want to talk about, well, how does that affect what we talked about? See, what we talked about is the sum of all the angles, okay? And so let's think about this. Here in this situation, we said all these sides are the same length. And not only that, but all these angles are the same measure, they're congruent as well. Then and we talked about what all of the angles add up to be, then I would be able to say, if I didn't know how big this angle was, I could figure it out because I know that all the angles are the same size. And so in this case, I could use that formula. Remember, we had that polygon angle sum theorem where we said the sum was equal to n minus 2 times 180, where n represented the number of sides. So in this case, that would be 8. 8 minus 2 times 180. And 8 minus 2 is 6. 6 times 180 is 1080. And so all of the angles inside any octagon have to add up to be 1080 or 1080. But because this is a regular octagon, then they're all the same size. So we can take that 1080 and we could divide it by 8. And 8 goes into 1080 exactly 135 times, which means that each one of these angles is 135 degrees. Because we took that 1,080, divided it evenly among those 8 angles, and that means that each one has to be 135 degrees. Okay? Let's try this again. I know some of you might be kind of on the cusp of getting it, maybe not quite tracking with us 100%. So let's change the shape and let's do it again. Okay, this right here is meant to be, it's not a perfect one by far, but this is meant to be a regular pentagon. Pent means 5, gon means side, so 5 sides. Okay, and so we say this side's congruent to this side, congruent to this one, this one, and we're saying that these angles are congruent. Now again, I know I can do this one, it's not perfect, but we're gonna pretend, okay? And so if this is a regular pentagon, we know that the sum of all the angles is equal to n minus 2 times 180. And this one has 5 sides. So we go 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180 is 540. Now that's what all of the angles add up to be. In any pentagon you have, any 5-sided polygon you have, they'll always add up to be 540. But because this is a regular pentagon, then we know that that 540 degrees is distributed evenly. And so I can take that 540 and say, what is 540 divided by 5? And I get 108, which means that that angle right there is 108 degrees. I hope you're seeing how easy this is. This is really simple stuff, okay? We got to come back to this idea that regular just means all the sides are congruent and all the angles are congruent. And then we go, wait, I already know this sum. We already have this formula to figure out what all the angles would have to add up to be. And if they're regular and all the angles are congruent, then we know we could just divide it evenly and figure out how big those angles are. Again, here we use that sum as well. We figured out what they totaled. We knew they all had to be the same amount, so we just took that total and divided it by 5 and figured out that the angle had to be 108. So let's try this one more time, and I think that you guys are going to be able to get this one. Now again, not a perfect figure, but this is supposed to be, man, this is a bad one. This is supposed to be a regular decagon, and dec means 10. This is meant to be a regular decagon. It's kind of like a regular decagon that somebody sat on, okay? It got a little smushed. But this side's supposed to be congruent to this one, 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 and this one, and all of the angles are meant to be congruent all the way through. There we go. All the angles are meant to be congruent. Okay? Now, what I'd like you to do is we're going to pause the video for just a second, and I want you to see if you can figure out how big is this angle if they're all the same size. Remember, we said that this is a decagon, which means that has 10 sides, okay? And so if all the angles are the same size, and remember we can use that formula for the sum is always equal to n minus 2 times 180, okay? The decagon means 10 sides. The sum is n minus 2 times 180. Now what I want you to do is figure out how big does each one of those angles have to be. Okay, so we're going to pause the video here for just a second, give you like 30 seconds to try it, and then we'll talk about the answers. All right. When we're back, let's try this. Okay, so what I would do is I'd say, well, I know it's going to be 10 minus 2 times 180, which is 8 times 180. So therefore, 8 times 180, I believe, is 1440. And so 1,440 degrees is what all of the angles add up to be, but it has 10 of them. If it has 10 sides, it must have 10 angles. And so I take this number, divide by 10, and I get each one has got to be 144 degrees. So I'm going to get rid of this question mark and put 144. Each one of those angles is 144 degrees, and hopefully that's what you got. But I have great news, okay? I'm hoping right now, in my other class, I said, hey guys, how many people, raise your hand if you think that this is pretty easy. And more than half the class raised their hand. I hope if I asked that question to you all right now, you would have the same response. If I said, hey, is this pretty easy? Everybody would be like, yeah, it's pretty easy. Great news. This is the harder of the two ways to do this. There is an even easier way. Now, I wanted to walk you through this way because it's so logical, but I want to show you something else. There's an easier way. And what I'm going to do is I'm going to zoom in on this one to help you understand the easier way. Think about if we extended this side right here. Then now we have created right here an exterior angle. okay? And if the interior angles are all the same size, then the exterior angles would have to be the same size. But the neat thing about the exterior angles is we know that the sum is just 360. No matter how many sides it has, we don't have to do the n minus 2 times 180. No matter how many sides it has, the exterior angles always add up to be 360. So if this one has 8 sides, then we could take that 360 and divide it by 8 and get 45 degrees. And that's what that angle has to be. It's got to be 45 degrees. And if that angle is 45 degrees, then supplementary to it over here would have to be 135. And look, this works for everything. It works for this pentagon right here. We could extend this side and go, this is an exterior angle. The exterior angles always add up to be 360. We could divide that by the 5 angles that there are, and we would get 72 degrees. And that's how big this one is, 72 degrees. And look, 72 and 108 are supplementary. So if I gave you how many sides and you knew that it was regular, then you could figure out the exterior angle even easier, and then you know that the interior angle is supplementary to it. Okay, so lastly with this one, imagine that we'll do that one more time. We extend this side right here and go, this is an exterior angle. All of them add up to be 360. If we divide that by 10, we get 36 degrees, and that's what that one right there has to be. And so if that one's 36, then the angle right there, right next to it, because these two angles are supplementary, then the angle right next to it would have to be 144, because 144 and 36 are supplementary. So, how do you do this? Man, oh man, it sure seems to be a good idea to understand that the exterior angles add up to be 360, and I can just always take that and divide it by how many sides and how many angles I have, and I can get what the exterior angles are, and know that the interior angles have to be supplementary to it. But remember, I can do it the way we started at the beginning also and say, but I can do it by the sum, and use the n minus 2 times 180 and just divide that number, because that was not hard. Up until 3 seconds ago, we thought that was the easiest way possible. So really, this is a pretty simple thing. So what I want you to do right now is I want you to go back and I want you to try some problems on your homework. I want you to do these 3 problems right here. Okay, I want you to try these 3 problems now using what you know, especially because it says each is a regular polygon. So now you can figure this out. Now I do dislike number 2 because they did a heptagon or a septagon. It's actually known as both. It's got 7 sides, and 7 does not divide evenly into hardly anything. And so it gives you a little bit of a mess, but that's all right. We'll get over that. But what I want you to do is I want you to try numbers 1, 2, and 3, and you're going to see how simple these are. Also, you're going to look at your homework, and you're going to do numbers 10, 11, 12, 13, and 14. You're going to give those a try. And on the back of it, you can do that top half now, where it gives you the measure of the interior angle. You're going to try to figure out the number of sides. And it has a couple more figures that look kind of like these, and you're going to try those. Okay? So what I'm going to do is I'm going to give you about 5, maybe 8 or 9 minutes to try to complete some of the things that you were unable to complete before on your homework because you didn't know what the word regular meant. Now that you know what the word regular means, you can do a little bit more. All right? Good luck, and we'll go over it in just a minute.